Hey, good morning everyone. Nice to see you. Buenos dias, dobro ranku. Just let me know if you can hear me well, see me well, because this is the first stream in like 2 or 3 months, so something's gotta be missing, but I'm not sure exactly. So I'll give a couple of minutes until we check if already. Hope it'd be good. It'd be good. Hey guys, nice to see you. And meanwhile, I want to thank you all for the support. The support on Patreon has been growing even though I haven't been streaming. I decided to stop the building on Patreon because I didn't stream, but I'll get back, and I got back eventually, so I will be streaming now, so it's again. Hey, and while I was on this break, my course has been released. I hope you liked it. A couple of people mentioned that there was no resize part, but that's because there was not just enough time to do that. Maybe I will do it in one of the streams, or maybe in the second part of the course, because it's not really complicated. You just gotta do those computations. The resize, change the sizes of the images, gotta recalculate everything and set it again. Good morning to India, good morning to Germany. And also, guys, yeah, let me know which country are you from, because it's always interesting, always inspiring. So today, this is the first stream and I wasn't really sure if we can make it work even. I decided to pick a simple theme, although a couple of people asked me about that in the past, how to do that from time to time, so I decided I'd show you how you can do that. So what I'm going to be showing you is like how to create a planet and some like kind of an airplanes on the planet, a little bit of the interactivity on 1 a.m. in Los Angeles. I believe it's gotta be 3 a.m. in Mexico. So last 2 months I actually spent in Mexico. Yay, Poland. If nice. Cameroon. Great. Oh my gosh, it's gotta be 2, 3 or 4 a.m. in Mexico, I think. That's crazy. Actually, I'm still sleeping on the Mexico schedule. We go to sleep at 5 Ukrainian time. So let's get started. Let's get started doing something. I believe it's gotta be a short stream, but I always say that and it turns out to be like a 10-hour stream. Anyway, I'm gonna call this stream Planet. Such a surprising title. Good morning, Momenta. Buenos dias. I can't speak Russian, but most of the people wouldn't understand me then, so... Australia! Oh man, this is crazy. Now we have the full geography. I believe... Okay, let's just continue and see how it goes. So, because I actually, while I have been in Mexico, my laptop drowned in the Pacific Ocean. So that was a really epic death of my laptop. I'm now on a 8-year-old laptop from 2013, I believe so. Yeah, so this is 2013 laptop, which is actually working pretty good and which has a nice keyboard. So let's start. I'm gonna try to start parcel now. But obviously I don't have like most of my setup on this laptop yet, because like the death was pretty sudden. So it was Planet. And then I gotta switch to, yeah, you always use NVM. If you have a new laptop, use NVM, don't use just... Right, and then parcel on this one, so I'm gonna start it. I don't think I even used VS Code much back then, so I wasn't mostly only Sublime. So we're gonna be using Sublime now. Okay, at least parcel runs good. So if we just... How to do simple SVG editor on the web. I believe some of them are already created. Just Google, because the drag and drop packages are there. You should just connect SVG to the drag and drop package. I think there's a lot of them. So maybe in the end of the stream, if I have time, I'll Google that for you. That's not really... So So. I think I should change the screen, right? How about that? Right? Make myself a small one. So for now, it actually works pretty good, right? I think on the stream I see some white line on my shader for some reason. Hope you don't see that. But anyway. Yeah, right? Is the screen alright now? Do you see the stuff? I'm gonna open up the code now. Yeah, I hope to release more courses like in the following month probably. Supposedly, I might also have a live workshop on the awards website because the support on the awards has been really great, and there's a lot of people who are interested in WebGL. So obviously, I'm interested in doing work on the awards website, right? And the guys are pretty cool, so why not? So here's the Sublime back on Sublime. And this is my usual boilerplate, which you can get in the course, which you can get on a Patreon. You can just type yourself in 10 minutes because it's not really complicated. But anyway, so we got this, right? So first of all, I want to create the planet. I want to create which planet we would like to create. We will have a huge choice of planets, and I'm gonna pick this one, I guess, because I'm originally from that planet. Only because of that, I'm gonna pull this one. So there are websites where you can just get the textures. I think just without the planet, probably. Shader relief. I think shaded relief. I think this is the way. Yeah. So they got a lot of textures here. I think there was also the other website where all the textures were. So you can find the Mars texture, you can find the Jupiter texture, Saturn ring texture, you can find any planet texture actually on the web right now. Why do you use iOS at work? I'm not sure what you mean. I use it at leisure, like use it on my phone. I don't usually use it at work. This is just my default phone. All right, screen is good. The courses should be released soon. Yeah, I was creating courses while I was in. It wasn't kind of a vacation. I was still working there, but I just couldn't stream because of not stable internet. Right. So, hey guys. So I think we should start with just getting the Earth texture. I believe I used the other website. This should be the other website. 2K. This one. Yeah, this is pretty old school website, but still you got all the textures. So okay, zooming is working. Nice. Right, so we have the any kind of resolution texture. We also have the bump map, which is like the height map of the Earth. You could probably see where all the heights are concentrated on our planet, which is actually kind of an interesting information in itself. And there's also the specular map, which kind of just highlights the ocean, the water part of the planet. And then there's night, right? This is just night map of the planet, and some more like clouds and whatever. So I'm gonna just get the usual 2K because fancy man. Should have probably used 1K because of age of my laptop. But anyway, it's been such a long time. It feels so weird to stream. I'm gonna call this one Earth JPEG. And well, to create the planet is actually quite simple. So because I'm using parcel, I'm gonna need to import everything. So I'm gonna give you a map. Earth JPEG. So yeah, the trip to Mexico has been crazy. Grounded my laptop, I've broken my rib, I've lost a couple of tickets, but I'm so happy. We have the map. So obviously, what's the shape of the planet? Does anybody know what's the shape of this planet? think it's kind of a sphere. Not really, but you can approximate it with a sphere. So for now, I will just create the sphere. We got the sphere. I'm gonna change the. I'm gonna probably make a layout so we see everything at the same time. And I stop changing windows all the time. Unregistered Sublime, alright. Because I have the license. I've bought it from my Patreon supporters actually, so I have the license for the Sublime. Just not on this laptop. What are the small turtles? Alright. Straight to the business. Here are the small turtles. They are actually the reason why my laptop drowned, because I was looking at them for too long and then the tide came in. Then I need to get back to my hostel and the wave flipped me with my laptop. Don't even ask me why I took my laptop. See the turtles? This is pretty awesome, yeah. So you could see how those are being released. It was pretty awesome. This is exactly the reason why my laptop drowned. So like, no regrets officially. No regrets. This is magical, right? And to see it in person is. Gotta go to Mexico. You gotta go to Mexico. They are very cute. You can even take one and give her, like, him a name, and then release it to the ocean, and then you'll have your own turtles swimming somewhere in the Pacific. Ever? No. No. So we have the planet. For now, I don't think I will need the shader material, so I'm gonna just override this one. It's gonna be no autocomplete here, but I know what to write actually. Load and then the map. And expected, yeah. Tirila. Tirila. Is run now. So time of undefined, of course, because I was updating the uniforms here. Now we got the planet. This was kind of easy, right? It's just it takes just the texture and the sphere buffer geometry and chat. Hola, amigos. All right. Hola, amigos. So we have the planet, right? We can also connect the bump map and the specular map. Let's just do this a bit later. First of all, like the first problem that a lot of developers face when they create those planets for some like business kind of a website, then the business owner actually wants them to like highlight some of the cities on the map. And how do you know where the city is? Because this is not actually the like the coordinate, the Google. It's not actually the Google map. It's just the JPEG which you like kind of wrapped around the sphere. So how do you know where exactly to position something? So one of the favorite cities that I met on my trip in Mexico was actually Mazunte. And you can grab the Mazunte coordinates just like that. If you Google like any city coordinates, like Kiev coordinates, I'm gonna get the Kiev coordinates. There's one important thing: north and east hemisphere, north and west hemisphere. So these are the coordinates, like latitude and the longitude. We gotta convert them somehow into the actual like, Three.js coordinates. So let's just do that. So first of all, I'm gonna put something here. So after I added this plane, which is actually kind of a, by the way, it's just one letter, turns out to be right. Planet, not a plane, right. So add. So I'm gonna create some kind of mesh, like stupid mesh, just so I will be able to add something to my scene. What's that gonna be? Here, buffer geometry again. And just red. My laptop is kind of exploding with all this with all the parcel running in the background right now. All right. There's a lot to learn about Three.js, and this is one of the like kind of a tricky things. It's kind of a simple thing, but then there's some couple of small tiny tricks to just to make it right. So I hope this knowledge which I will share in this video helps someone. Helps someone. So then I could just add this to my scene. But the problem is I need to set some kind of position for this one. So position set, let's say 1, 0, 0. So it's because the radius of my planet is actually 1. So if I put something into 1, 0, 0, I should see it on the pole or see it anywhere. Of course. See it. Mesh. Oh, this thing. Mesh. What's on here? I'm just adding. I'm just adding a simple. Oh yeah, it's there. It's just from some different kind of weird site, I guess. So yes, it was actually there. It reminds me of a clown. Am I wrong? Kind of. To think it's kind of a clown. Okay. So we have the pin, we have the mesh. Now we have to calculate the correct positions. First of all, I'm going to take the Mazunte coordinates, and these are these. So these are in degrees, as you can see now. Latitude and longitude. So these are in degrees. To like, there's such thing as a spherical coordinates. Spherical coordinates. It's kind of a polar coordinate system, but in 3D. So we just have two angles here. One angle determines like in the what's that, like xz plane, in this case xy plane determines the angle, and the second one determines the what's that, your angle, right? And then there's a radius which determines like how far the point is from the center of coordinates. So it takes actually two angles and some distance to like, this is actual spherical coordinates. Like in the Cartesian coordinates, we have three coordinates like x, y, z. Here we have the radius or the distance and two angles. So these coordinates, the latitude and longitude, are actually kind of spherical coordinates. And because I assumed the Earth is actually a perfect sphere, it means that the radius is always 1. Well, of course, it fluctuates, obviously, because we have some mountains and so forth, but we don't yet have them on my planet, so on my planet. So we can actually assume that the radius is always 1, and we should just calculate, this. This is the Cartesian coordinates, right? And these are the spherical coordinates. We should just calculate some conversion between Cartesian and spherical, and this is it actually. This is how I calculate from the angles the coordinates in Cartesian, from the spherical to. So let's just do that. First of all, if we're going to take some sines and cosines in the JavaScript, they're going to be expecting some radians, not actual degrees. So first of all, we need to multiply this one with 180 divided by math. Actually, the other way. Math pi divided by 180. So we're going to divide the angle by 180. This way we're going to get the value between 0 and 1, which we can multiply with math pi and get the actual radians, the actual radian angle. Byte instead of parcel. Thank you. I gotta try that because parcel, yeah, parcel has been like has seen a lot of updates recently, which I don't really. That doesn't make it more comfortable to me. Thanks a lot. I gotta try that. I'm gonna even put a comment here. All right. I don't like math. When did I say that? Yeah, we're making a planet and then I'm gonna show something on that planet. So right now we're just converting the coordinates from the latitude, longitude, which you can Google, to the actual Three.js kind of coordinates, so we can put some pins on the planet, even though it's just a texture. So now we have those angles, like latitude, longitude in the actual radians. Now we could use this, right? So let x equals, because radius is 1, it's gonna be cosine of the, like, this are the angle. So it's gonna be sine, cosine from one angle, and then in the end it's a cosine from the last angle. So it's gonna be, how to not mess it up? Actually, maybe it's better to use the other variables because it's not really latitude and longitude anymore, it's just some kind of radian angle. But anyway, so it's going to be cosine from the longitude, I think, and then multiplied by math sine latitude. Then the other way around going to be sine from this, and then in the end it's going to be cosine from and this should be xyz. So I don't think we would make it right from the first try, but let's at least try and see where would we put this pin, where would we put this pin on our kind of Google map. So somehow it's actually correct. Because Mazunta is roughly in this place. So let's try something different, like Los Angeles, for example, just to see if we are really making things correct. Because I believe we cannot. It's just the Mazunta is so close to the equator. I need Los Angeles. So it's 34. I'm just gonna. This is kind of correct, right? I think that's where Los Angeles. Maybe not. I think that should be right. Gotta make the pin smaller. All right, gotta be smaller. Like it's like this. Well, now we're getting like kind of a mistake because this is not really where Los Angeles is. I think so. It's gotta be somewhere here, I guess, right? But it's not. So that's how you like realize that there's actually some kind of mistakes in this formula. Not really mistakes. It's just that it's kind of a bit more complicated than that. It's not just angle and then you turn them into spherical coordinates. So they actually work a bit different than spherical coordinates. And I think you gotta tweak a little bit those angles just to get them right. So first of all, is now there's a couple of like dangers or the mistakes that are possible. First of all, the texture could be flipped. Second of all, the texture that I'm using, you know that the angles, like those latitude and longitude, they actually start at Greenwich, right? Which is kind of in England. Kind of, it's actually in England, right? But I mean, this map, it doesn't start at England, right? So we have some kind of offset, which we have to account for, probably. And what do we do about that? What do we do about that? There's also this part where I think it could be either sine or cosine. So first of all, let's switch for a minute to Kiev. Kiev coordinates. Like a little simpler. It's gotta be this. Then what's north, eastern. It's not really where Kiev is, you know, unfortunately for me, because I like oceans, it's not really where Kiev is. And why is that so? I think we might try to shift the coordinates 180 degrees maybe. That didn't help much. Now there's also a possibility that I messed up the sine and cosine part. So this could be, so just to change sine from cosine, I could just subtract this angle from 90. Maybe this is kind of yeah, Los Angeles is not in Mexico. So yeah, there's something wrong that I did in those calculations. And honestly, I do that every freaking time. Every freaking time I do this latitude longitude conversion, I get something wrong. Like it's either sine, cosine, or the angles, and then there's gotta be some minus or plus things depending on the hemispheres that I'm using. So let's just try this. Yeah. Please remember that right. Oh, that's completely wrong. So I think one of them gotta be minus. Let's just try that. Doesn't look right at all. Where did I mess up? Did I even copy the correct coordinates? So key coordinates is 45, 30. I think I messed up something here. So this is the cosine. Maybe I start with sine. Yeah, this seems actually kind of better. We're actually getting closer. And now I think if I just add something here. No, it's not the way. So maybe this one is also should be cosine, cosine, sine. Ah! This is so embarrassing because I had it right, but I just spoiled something and now I messed everything up and I'm confused. This is just gotta be a different kind of combination between sine and cosines. And I'm just gonna concentrate, make it right. So which one is the latitude actually? Am I doing this right? So this latitude is 50. This is kind of right, seems right. This is latitude. Then if I go here, I think this one's gotta be cosine. This one's definitely cosine. Not. Oh, I know. Yeah, for the angle, yeah, but I think the mistake that I did, well, it's just one try. Well, no, that's not it. I think one of the coordinates has to be with a minus, if I remember it right, because of the texture, like because of the texture flipping or something like that, one of the coordinates has to be minus. That has to be the x coordinate. That's what I messed up. So if I just return to maybe everything I did before, offset, which results to me. So this one, the latitude, it should be Sine, cosine. This has got to be maybe cosine. Sine. Still not there. Still not there. So the latitude. yeah, you've gotta add the 180 to the last. That's definitely the right thing to do. Still ending up on the different hemisphere. Well, the coordinate's kind of right. It just has to be flipped to the opposite. You know, I can already see that this is the right. What's that? Latitude, but I gotta flip it all to the like. This is the kind of an opposite part of the world now. Oh god, oh god. So sine, cosine. So first two should be actually sines, and the last one has to be cosine. And this has to be the first two sines, and then the last cosine. We end up here. And then first one is the sine from the latitude multiplied with the sine, both sines actually, right? And the last one is cosine. Maybe also flip this one. I don't know what I did wrong. Maybe I just used a different kind of texture. This is so embarrassing. Spending 10 minutes on fixing this fucking the reason of this stream. Okay. Okay. So then we have the sine from the latitude. Again, sine from the latitude. I'm just gonna change the formula a little bit so it's more clear to me, because right. So it's sine latitude, and then cosine latitude. These are cosine and sine. And longitude is with 180 degrees. That's gotta be right. And then the latitude is something like that. Gotta be right as well. So this is exactly the opposite spot from the from Kiev. Maybe it's just that. No. Oh god. Oh god. I think it's time for a total break. Yeah, that's right. So whatever happens, we're gonna use the wrong coordinates and then fix them later, because I believe this gotta be some stupid mistake, because I did everything right. This is the right formula. I mean, there gotta be some minus somewhere here and there, but the formula's gotta be right. This is the right one. Maybe though, one of the coordinates has to be with a minus for Kiev. Not this one. Let's try all of them. I'll do my last try. Fix this one. No, okay. Screw that. So we're gonna use the wrong coordinates to build some paths. So what I wanted to build is actually the path on the planet Earth. I actually had a stream already where I used this formula. That's why it's so funny, because I actually used it, but now I'm kind of stressed. So yeah, that's why this is a problem. So I'm going to use random coordinates. So I'm going to use like, let's point latitude. And I'm going to fix this function. And then I'm going to use 0.2. The first one was Kiev, so the second one, let's be Mexico. But these hemispheres is gotta set somewhere minus to make this right. I think on the first coordinate it's got. All right, so we have 0.1, 0.2. Let's also do the function, like function convert that longitude to radian. And then it's gonna be like that longitude. And then I'm gonna put this formula in there. Yeah, the Corson Awards. Thank you for thanking me, Corson Awards. It's so embarrassing about this longitude. Okay. Turn x, y, t. And then just to check this formula is working, I'm gonna convert actually 0.1. So it returns me something good. And if I get this object point, it means that I'm gonna using this p, and it's gonna be the latitude, longitude. So this is the formula. This is gonna be returning me something. Let's see. X is not defined. X, which is this. All right, so I get the coordinates. The function kind of working. It doesn't return me, of course, the correct coordinates, but still. So I get this pos, and I could set it here. It's gonna be the wrong point at the moment, but still. So it's somewhere in Argentina, I guess, Brazil. So let's create another mesh then. So pos and pos1 is gonna be 0.2. It's gonna be 0.2. Let's create another mesh and make it green. Add both meshes to the map. No, I don't stream in Russian anymore because a lot of people watch me in English now. So they wouldn't understand me. So the mesh one, maybe I'm gonna do like 50, 50. So it's kind of close to the first one. We have those, okay, I believe I just didn't see the green point. So we have those 2 points on the planet, maybe even further. So we have those 2 planets. And what usually asked to do is to connect those planets with some kind of curve, or like how the airplane flashed from one planet to another. And that's what I wanted to show in this stream. Honestly, I just wanted to show my trip with all the latitude, longitude, with all the cities that I've traveled to. So let's try to build this kind of curve between those two cities. How you do that? It's actually kind of an easy task with the with math, I guess, right? So we have 2 points. We have then 2 points in the Cartesian coordinates. But if I just connect them with a straight line, I'm gonna get the line inside the sphere, because the sphere is some coordinates, right? So to do that, I actually need to build some curve between those points. And for this, I'm gonna use the tube geometry. Alright, so I have to use some curve and then I have to use it like this. So get curve, and then there's gonna be like point P1, P2, 2 points. So let's try to do that. So first of all, we create the geometry out of some non-existent yet path with some parameters. Then we have the material, which is just green. Let's make it blue. Then we have the mesh, and we add this mesh to the scene. So what we need to do is we need to do this path, actually. We need to build this path. And to build this path, we could actually use some, like, there's a custom sine curve, which we can use, but we can also use the other kind of curves which are available in here. So it could be actually even a line curve. So we could just generate a bunch of points and then connect them. This line curve just connects 2 points. I don't really like this one. I need to connect a lot of points. So I'm going to be using Catmull-Romcore, which accepts the array of points and then just connects them. All right. So which points I'm going to use here? I have already 2 points like P1 and P2, which are like 3D points. Now I need to generate some points between them that are on surface of the sphere. So first of all, in Three.js there is Three.js yeah, minus 77. Yeah, that's why I mentioned that it's going to be minus for the hemisphere. Okay, we're going to test on the Washington. So generate points between two three-dimensional points. You could also you could just use your math, but there is this thing which generates you some points. So let's say I want 0, 20, and then I want to lerp between two vectors. I want to get the point in the middle between two three-dimensional vectors. So for this, actually, so we have two vectors for the start and the end of our curve. And then I can get all the points in the middle. And to lerp them, I lerp vectors and then 1 equal to an alpha. Okay, seems easy. And what's the alpha going to be? It's going to be something between 0 and 1. And between 0 and 1 means between 0 and 19 in this case. 20. This is going to be I divided by 20. Right. And then I could just put this P and see something is working in this string. So we got 20 points. They're kind of close. You can see just watching one of the coordinates, you could see that they're lerping between two three-dimensional points. And the path is not defined because obviously I had to create this path now. So I have the array of points. So let's points array, then points push this P. I have the array of points, and now I can build the curve. Now I could do the red curve. And then points, right? And this gotta be correct curve. This is actually the path that I'm trying to build. Let's see if that works. Well, it should be working. I'm just not adding anything to my scene now, but the curve has all the attributes that I set. So right now I could just create this. Oh, actually, I was actually creating this mesh. For some reason I don't yet see it. So I have the path, I have the geometry, the mesh basic material for the geometry. I'm creating this mesh and I'm adding this mesh to the scene. Where is it? Maybe it's gotta be that huge that we don't really. Yeah, the curve is just so big. It actually kind of connects the points. You could see that it actually connects in the points. Now we could go to the tube geometry docs. So I don't really remember which parameter is for what. So first is the curve, second is the tubular segments, which I think 20 is all right. Then the radius, then the radial segments. So I think that this is the radius which is too big. So the first one is the tubular segments, the second one is the radius. It's got to be something real. Yes, now we have this connection. It goes under the sphere because, as I mentioned previously, if we draw the straight line, it's going to go under the sphere. So how do you use it to go like over the sphere? Because obviously what I want to do is to do some nice curve, which like an airplane path, right? It goes on top of the planet and then goes back again. All right, so how do you do that? There's actually also a functionality in Three.js which helps to do that. And to do that, so first of all, when we get in this point, I could normalize it. I don't really need to normalize it, right? Because it's I could actually normalize it, right? Normalize. First of all, if I do this, we're going to put the curve on a sphere, because when you normalize vector, you make this vector of a length 1. And if the vector of length 1, it's just all the points in a sphere. That's the definition of a sphere. Those are all the vectors that are at the same length. I just this problem. All right, so now how you go over the sphere here. I could scale this vector actually. So I could not only normalize it, but I could also scale this vector. I could do this. I could do oh, you didn't do this. Multiply. Color. Let's say I'm going to multiply it with 1.1. Just going to be right on top. So what I need to do, I need this value to be 0, like I mean 1. It's going to be like 1 plus 0.1. So I need this value to be 0 at the start of the point, then the maximum like 1 at the end of the point, and then again 0 at the end. So there's one function which is really helpful in doing exactly this. You could just go so this is exactly what sine does. It's 0 here, then it goes to the top, and then it comes back. Of course, you could use some other functions. There are a lot of functions with this same behavior, like with different curviness, but this one is pretty fun to do. So we have some parameter which runs from 0 to 1. This one runs from 0 to 1, and we need some parameter which is going to be between 0, 1, and then 0. This is actually pretty easy to do if you remember how the sine behaves. So it's just going to be math pi multiplied with I divided by 20. Because when the x changes between 0 and pi, this is actually pi 3.14, it does this curve between 0 and pi. So this is what we're gonna have now. Let's try that. Well, this is awesome, but I think too much, right? Because it used to be like 0.1. This is how you get those curves on a plan. So this is actually kind of an idea for the generative art project. You could just generate like lots of points on a sphere and then connect them with those arcs, and then you're gonna get like something interesting here. So now, now it's time to get back to this. This is gonna be painful. If there are some children watching this stream, please remove them. Nobody's gotta see this. So we gotta fix this formula finally. And let's use Washington, right? Why not use Washington? Because it didn't work with Kiev and Los Angeles, so just so that. Okay, so the Washington 38. I'm gonna just trust you. So it's gonna be 38 and then minus 77. Now I just gotta fix this formula. So it's kind of close to where the Washington should be. Not quite, but kind of close. And you can see these curves are actually working pretty good. Like anywhere you put those 2 points on a sphere, you will always connect them with this perfect arc. And if you need more detailization, you could do even better. So what I wanted also to show how to animate these arcs, how you could like do the flying kind of thing on maybe just some movement. But we need to fix this thing first. Apologize, guys. All right. So gotta fix this formula. I remove this minus for a second. I might also remove this curve and this. Should we just see the right one? Now it puts it somewhere here. I have a reason. Move this as well. There's something really wrong here. Something obvious probably, which I'm missing. Gotta be something obvious. I don't know why I'm missing this. So at least for Mazunte it worked well. At least for Mazunte. So longitude, latitude. I think I had this formula in one of the projects that I used to build. Just to look it up, and then we do the backwards kind of programming, because I think I just made some simple, really dumb mistake. I tried to make an obvious explanation and I failed. To the wrong path. So P latitude, P longitude. Okay, let's just also check if this one is correct. So that one kind of right. We have the position and we set the mesh position X, Y, Z. Correct so far. It's gonna be math sine from the latitude. Okay, let's just also check yourself. Well, that seems right. Seems right. So we're normalizing for the minus, for the negative values here with 180, which should be right. We should have at least got the right longitude. Okay, let's this find latitude. Maybe these ones are wrong. Oh, that's crazy. This is so wrong. This is so wrong. This is just funny that I've managed to mess this up. Yikes. The hell is wrong here? Ah. Maybe something real simple. Okay, I'm gonna look up the. I think I had it one of the projects that I did. One. This one. I think here got this formula. But it's. Yeah, I believe there's gotta be some simple mistake. So let's just try this function. Just try it. So we have another function here, which is kind of the same. I don't think I need radius here. There's still the minus here. And do it this way. Yeah, I'm not sure. I think that might be like, I might have used the wrong texture or something, but I'm gonna just check myself with these functions that I used previously. So I guess the offset is kind of wrong on the map. So I'm gonna do this, it returns the same thing. Right. From longitude. Where's my point? It's none. Oh, because I'm putting, yeah. This is actually right now. This is right now. So let's just try Los Angeles. But they look similar. So Los Angeles is going to be 34 and then minus. Now what's the difference between those two? Oh God, help me. So that was 90 minus. So maybe this is just. Let's not even stop on that. Well, I'll send you a postcard if you spot the difference here to the first one. One of them is working, the other one is not. Let's try also on Kiev. It's gonna be 50. I'll pick it for the second one. 50 and then 30. And then right. I think one of them has got to be minus. This one, this one. One, two. Now still something is wrong, right? Couldn't be right because I can't get the Kiev. We could just stay in the States, like in the USA, right? Why should we go anywhere else? Oh yeah, because I'm still using the wrong function there. That's why I get the wrong results. When you made one mistake, you begin to be stressed out. You make a lot of other simple mistakes. Then, yeah, no. One of them should be minus, right? Because of the hemisphere. I think the first one. Yeah. So because of the hemisphere, you gotta change the coordinates sign. So even when you Google like the Kiev coordinates is actually 50, but because it's in the north hemisphere, it's gotta be minus 50. And the same goes for Los Angeles. Even though it's 118, it's gonna be minus 100 because it's a western hemisphere instead of an eastern like in Kiev. So when you Google those coordinates, you gotta change the plus for minus. And if the formula was right, I think I just messed the sine cosine part because it's just 5 sines and cosines. And that's a jet lag. Let's blame it all on jet lag and the turbulence. All right. So this is the correct formula. To get this one, it's got to be commented and burned down. Maybe I will check later what was the actual mistake because I'm kind of curious, like where was the actual mistake? So it's right now, I'm going to show you in the end like how you could animate the curve. So I'm going to add the curve as well between those 2 points. Yeah, so it looks like this. But the key was just right. Just a second ago it was right. Okay, let's just change to something so it's right. Yeah. So you don't have to put any minus on the key. Ah, head exploding. Yeah, I guess this is because of the double sign. Yeah. Okay, whatever. The dumbest mistake are the hardest to fix because you seem like everything is 99% right. You just can't spot this freaking mistake. So these are the coordinates. Now if I add the curve, we'll get the curve between Kiev and just like that. And it's kind of like the airplane flights actually, because it flies through all those things. So what I wanted to do actually, I wanted to show you like the trip that I did. The trip that I did was from Kiev to Qatar. That was 25 north. So this is going to be the point 1, it's going to be the point 2. So first of all, I flew to Qatar because I couldn't fly to USA because of the COVID rules, and I lost my ticket. Yeah, that's how it happened. And from Qatar, I flew to Chicago. Chicago coordinate. One of them's got to be minus. Minus. So we mesh 2. Actually do it like this, mesh 2. And then could have moved it to the function probably. So far just to make it work. So this is from one place to the other, and then this is going to be from position. So far, just one thing about it. Maybe there's some mistake. No. Oh, I just didn't refresh. So actually I had to flew to Qatar, which seems like the opposite direction at all. Now that I see it on my Google Map plan, Google Earth, like Earth. Now that I see it on the planet. So I flew to Qatar first, and then I flew back to Chicago. Then from Chicago I flew to Dallas. Like, let's add another point. Cancun. And that was not even the end. I just wanted to visualize my whole trip while the coordinate system is working, and then we're gonna try to find the mistake maybe. Yeah. You're probably right, it was a double sign. So Puerto. That's already the West Hemisphere, right? This is a Puerto Escondido, then Concord. These are kind of close, and then the Dallas. A pretty long flight, you can imagine. Right. So then I think it's better to move this all to the array. So like light. We have the 6 points in the array. And now I could just connect them all in a loop. I could make a loop. I don't like this loop. Flight length. I think -1 because there's gonna be no flight from the last destination, and then the cost is gonna be equal. What's that? What's it gonna be? It's gonna be the flight. This one is gonna be 1, like the next destination, and then I would need to create the mesh here. I'll just create the mesh for each of them. This. I'm going to add the mesh and mesh that. So right now I'm just I'm making a loop over all those destinations of my flight, and I'm creating the mesh, like this red pin for each of them, and adding to my scene and setting the coordinates of this thing. So it should work for me. I'm gonna leave the curves for now. Didn't work because pos is not defined. I mean, it's not defined. I'm just setting the pos here. Oh yeah, these curves. Yeah, so they seem correct because Cancun is roughly there, and Kiev is here, Qatar is there, Chicago is kind of there, so it seems right. Except the cancun. Cancun seems a bit off, but maybe you just no, it's actually right. I just don't remember where cancun is. So now I have to connect them, and now I could run this getCurve function inside the loop to produce curves. It's going to be pos and pos1, yeah, right? I could also make it a bit thinner, I guess. Yeah, and I didn't create the for the last one. I didn't create the last pin. I'm creating the mesh. Right, so I'm gonna do it like this, and then I'm gonna add the curve except for the last. Right, so this is a crazy flight that I took to actually get to Mexico. You can imagine. These are too many flights. And this is the way how you could build like those things. And this is not the end, by the way. You could also add something. I'm sorry, this stream is going to be a bit longer because I was stupid, dumb, and made a dumb mistake. But instead of using just the blue material for each of them, I could actually use something different here. So instead of using this mesh basic material, use this material, which is also mesh basic material. Oh, which is kind of funny because we have a lot of planets on each of the pins. Okay, so I guess this material shader. So we could now use this shader material here. Move this stuff. No, I just went there because I was very sad and I needed to get away from my city. From my problems, from okay, everything. All right. So, boom, boom, boom. Yeah, and the thing is, I also wanted to take the plane from Los Angeles to Singapore to make it even longer than that, but the COVID is complicated. The COVID is complicated. So I was looking for the get curve, and I wanted to change the material for my get curve. So it's this one. Yeah. So actually, for the pins, this is all right. That's what I wanted, the different material. And now this is a shader material, so we have the UVs. Now when we have the UVs, we can go to fragment shader and maybe visualize just the X coordinate of the UV. Let's see. It's not the coordinate I need. Probably the Y is what I need. Oh, that's actually the X. So it gets darker in the end. You could see that it starts red and then it gets black in the end. And this means if I also set the material shader to transparent true, I need to do. And then if I take the sign, like let's plot dash equals math sine of VUV x multiplied by 50, let's say, and then if dash below 0, just discard. This is the best way to do that, but it's gonna happen. Now we have those dots. So now if I just return the material shader time, and if I just add time here, everything will break down. Probably some JavaScript error, right? Because I haven't declared the uniform. Yeah, so maybe minus time. And now we have this directional animation. Well, we could also normalize the length of the dashes because we kind of know the length of the arc, so we could just normalize the length of the dashes. I'm not sure if there's any other options to do that. I would just use the attribute or uniform for the for each of the meshes, for each of the materials, to make them different, just to make the dashes equal. But that gotta be the other way, probably some easier way. Also think that these ones are just too. You could also add some shadows so they like get shadows on the planet. But you get the idea now, right? So with this simple formula, you could just create like all those paths on the planet, like visualize them, and it's quite simple, right? except this part, which was kind of the point of this whole stream, which I spoiled. I don't know. This still looks like, right? This looks similar. I mean, there are of course some sine cosine shit, but yeah. Even right now, I can't really spot the obvious mistake because the phi is the latitude. Anyway, this one is the correct one. This, right? Right. This one is the wrong one. I will check after the stream what was wrong. So this is actually it. Yeah, the axis with the minus, and it's sine sine, and here it's sine cosine. Ah, yeah. So it was still about sine cosine. I was just trying all the wrong combinations probably, and yeah, I really enjoyed the Mexico. México es mágico. Sí, entiendo español ahora. Yeah, and you can also regulate the curviness of those arcs, like curve with this parameter, like 0.1, just 4, let's say, and you could do this. I would also mark the parts of the video with a mistake, so nobody would waste any time, so you could just skip that part and enjoy only the correct content. So this is how you do that. It was also planned to go all the way here, but maybe that's gonna be in the next stream. We're gonna sleep better and do better. So that's kind of it. If you have any questions, guys, I'm gonna be happy to answer them because the stream is already quite long. So we could as well just make a short 5-minute Q&A session, and then it's gonna be the end of the stream. Thanks everybody for watching. Hope it wasn't too painful to you to watch my mistakes. This is so bad. Just one cosine definitions. Crazy. Maybe that minus as well, because I had this minus for I probably had the sine cosine part right, and then I put the minus and it was wrong, and yeah. Of course I enjoyed tacos. Not only tacos, also some playudas, also some what I enjoy most. Ceviche. Yeah, there will be another course on awards. Well, actually, I'm right now figuring out like what's the best approach to this course, because there's another course which kind of overlaps with mine. What I had in mind, I will just tell you what I had in mind for this next course, and you can just like validate my idea. So what I wanted to create for the next course, I wanted to show people how to do this. When you go to the Tao Tajima website, of course I had this stream about the WebGL transition from the Tao Tajima, like this one. It's a Russian speaking stream, but you can still watch it in the first season. But what I wanted to show you in the second one, how to do this kind of transition. So you scroll the page, you see the images, then you click one of them, and it does this. It just goes to full screen. This is just one kind of an animation that you could do for this. There are also different kind of animations. So I wanted to make like a tutorial, a couple of hours to how to create a website with smooth transition between pages, because you could see that the URLs are transitioning too. So we're going to the separate page. Like right now we are on portfolio page, and we just click the item and we go to some of the portfolio. Of course, I wouldn't be replicating like 100% this website, but these kind of animations, like going to full screen from any position of the page, like from this one, just goes casually to the full screen, and I like it. That's what I wanted to create. But there's another course right now with the OGL and the maybe similar effects, because it's not released yet. So I'm thinking now maybe I should do something different, or maybe still do this with the Three.js. So this is what I'm figuring out right now. Может быть, будет на русском, но не знаю. Я не могу обещать. Пока на английском все делаю, так проще, чтобы не переводить. Okay, anything but words. I gotta give them this feedback probably. Maybe they can fix it actually. So the streaming of video is slow, so because the CDN they are using probably is slow in your country. And what's your country again, right? So I could just give them the feedback. Maybe they will try to fix it, because I believe they are interested in people being able to stream with a high quality and high internet connection. This was the idea for the next short course on the awards. This is gonna be probably some kind of workshop where it's not like a course, but it's a 2-day thing where you go a bit more in depth and a bit more to the stuff that you like maybe you don't know, like starting a bit from the basic and then going all the way to like these kind of WebGL effects. Probably maybe something with the generative art as well. I don't know, something with generating graphics. Obviously, I would not include some Cartesian to spherical coordinates there, because it's gonna take some time to okay, I'm gonna tell them, so maybe they could try to fix it. Thank you for mentioning that. I didn't know this is an issue. Because even when I was in Mexico, I tried to watch the video and it was okay. For me in Mexico it was okay, and for me in Kiev it's also okay. But there could be some issues, I think, with some different countries, of course. Can you get a coupon for the awards course? But they always start with a big, huge discount, and when they start, I always tell to everybody in my Discord channel that they actually the sale has started, and they start like really low, I think $20 or $15. My first course was with $15. I don't know if you could get any like lower than that for free. I guess this is lower. Oh, thank you. It's kind of sad that we have this buffering issue, but I'm still happy that you thought it's worth the wait for the buffering. I will still send them in the email. I hope they will fix it, because like this is their business, right? They sell courses, they need to be able to fix that. So I hope they will do. Hey, hello to Ukraine too. This is crazy. I was so close. So close. So I guess that's it. It was 5 minutes. I'm gonna still stick in the chat for a while. Thanks everybody for watching. The first stream was a bit rough with this formula. I told you it's tricky. Like every time I try to figure that out, every time I fail, and then like this 90 minus. I believe this one could be replaced with the fee. Gonna be cost time like that. It's gonna be still working, right? Yeah. So it should have been 2 cosines here, not 2 sines. Then it would have worked for me. Yeah. So it's sine, sine, cosine, but I had cosine, cosine, sine. I messed up the sine, cosine order. That was the mistake. Hey, thank you everybody. Have a nice day. I hope you wouldn't make those mistakes. Remember, this one is right. So we were on the right path from the beginning. I think the Wikipedia was kind of misleading for me. And thank you everybody for watching. See you on the next Sunday. See you on the next courses. Go to my Discord chat. Ask me on Twitter or anything. And I will see you in a week. Have a good day. Do something good. Be happy. Be kind to people. I love you all.